Good evening guys, and welcome to today's video where I'm doing a standalone lesson on solving non-linear simultaneous equations. Right guys, this video is aimed at GCSE 9 to 1 for grade 9 students, okay, so grade 8 and 9 for GCSE curriculum for the AQA, EdExcel and OCR spec. Is also appropriate for A-level students, again for all the examples, and GCSE further math students for those of you doing the additional maths qualification for GCSE maths. Okay, so it is applicable for all exam boards. Right guys, before I start, if you found this video useful, at the end please subscribe to the channel, please like my video, please also press the bell icon so you don't miss out on further uploads, and also comment below on what topics that you'd like me to do for GCSE, Key Stage 3 and A-level maths. Okay, right guys, let's just start the video today. So example 1, solve the simultaneous equations, and it's a 4-mark question. Y equals x squared plus x subtract 14 and y equals x minus 5. Now we can clearly see, okay, so what I'm going to do is label that one equation 1, equation 2. Now we can clearly see that both equations has y equals, so I can set these two equal to each other and solve essentially. So I could say equation 1 equals equation 2. Now what this is essentially saying actually is that, so I'm going to have x squared plus x subtract 14 is equal to x minus 5. So when I solve this, guys, okay, it's essentially where this line intersects this quadratic graph, okay? So solving this, what I'm going to do is subtract x on both sides. I'm going to add 5 to both sides. Okay, so x squared plus x minus x is going to cancel, so I'm going to get x squared subtract 9, because minus 14 plus 5 is minus 9, is equal to 0, okay, because I've brought all these terms to the left hand side. Okay, so solving this, guys, adding 9 to both sides, I'm going to get x squared is equal to 9, and then x equals plus and minus the square root of 9. Remember that when I solve quadratics, guys, it's always going to have two distinct real roots, okay? So it's going to have two distinct real roots, okay, where possible. So x equals minus 3 and x equals positive 3. So when x is minus 3, guys, and x is positive 3, what are we going to get? So y equals and y equals, so subbing in minus 3 into equation 2, minus 3 subtract 5 is minus 8, and positive 3 minus 5 is minus 2. Okay, so this is essentially the coordinates at where the line, okay, intersects, i.e. crosses the curve. So it crosses the curve at minus 3, minus 8, and it crosses the curve at 3, negative 2. So that is the solution for my equations. So they are my solution to the equations. So x equals negative 3 when y equals negative 8, and x is positive 3 when y equals negative 2. Okay, so that is my solution for this equation, guys. Positive 3 and y equals negative 2. Okay, so this method, what I've done is equate the equation. So I've equated it. Both of them have y equals, so I've set equation 1 equal to equation 2, because at that point, that is when the graph is intersecting one another, essentially. Okay, example number 2, solve the simultaneous equations. Okay, so it's a 5-mark question. Okay, y equals x plus 3 and x squared plus y squared equals 149. Okay, so step 1 is label the equations. So this time I've got a line and I've got a circle. So I've got a straight line actually that intersects with a circle. So it's going to look something, obviously it isn't going to be drawn like exactly, but it's going to look something like that. Okay, so we're going to have 2 points at where it crosses. Now what I'm going to do this time actually, so I'm going to substitute in equation 1 into equation 2, because I've got y equals and then I've got a y squared here. So what I'm going to do is sub in equation 1 into equation 2. So I'm going to have x squared plus x plus 3 all squared is equal to 149. Okay, so I've just subbed in equation 1 into equation 2. So I've replaced y with x plus 3. I'm now going to expand this and solve it. So expanding this, I'm going to get x squared. Okay, now expanding this, guys, remember, I'm going to have x plus 3 times x plus 3. Okay, so taking my time here when I solve this. So what am I going to have? Well, I'm going to have x squared plus x squared plus 3x plus 3x plus 9 is equal to 149. Okay, so I hope you're with me so far, guys. So this is expanding this bracket. X times x is x squared. X times positive 3 is positive 3x. 3 times x is 3x. And positive 3 times positive 3 is plus 9. Right, guys, so the next step actually is, so when I combine the like terms, I'm going to get 2x squared plus 6x. And then I'm going to have plus 9, but I'm going to bring the minus 149 over because a quadratic has to always equal to 0. So what I've done here is minus the 149 onto both sides, so I get that. I can now solve this equation by factorizing it. So if I take out 2 as a factor, so sorry that it is a bit like a mess because there is not a lot of space to like do these questions. X squared plus 3x minus 70, okay, is equal to 0. Okay, so factorizing that, I'm going to get 2 brackets. It's going to be x plus 10 and x minus 7. Okay, so x plus 10 and x minus 7. Okay, so you can check that by expanding it. I get x squared minus 7x plus 10x, which is plus 3x. And then positive 10 times negative 7 is minus 70. So that is equal to 0. Now solving this, guys, I'm going to get that x is minus 10. And the x is equal to 7. So they are my solutions. Okay, if you're not happy with how to factorize quadratics, you're welcome to either complete the square or use the quadratic formula, okay, in order to find your equations. Yeah, in order to find the solutions to the equations is what I mean. If you find it a bit of a struggle, but feel free to check out my videos that I've made on factorizing quadratics. Like, yeah, I've done quite a lot of videos on how to factorize quadratics when the coefficient is bigger than 1 for the x squared, and also when it's less than when it's just 1 at the front as well. Okay, right, guys, so subbing this in, so when x is minus 10, y is minus 7. When x is 7, y is 10. So the solutions are minus 10, 7, minus 7, and 7, 10. So that's with the points out where the line intersects the circle, if that makes sense. Right, guys, example number 3. Solve the simultaneous equation x minus 4y equals 2, and then x minus 8y squared is equal to 8. Now, what I'm going to do this time is label this equation 1 and equation 2. So I'll try and make my handwriting a bit smaller so I have a bit more space. I'm going to rearrange equation 1. So I'm going to get x is equal to 2 plus 4y. So I'm going to add 4y to both sides. I'm then going to label this equation 3, and I'm going to substitute equation 3 into equation 2. So replace x with x squared. So I'm going to have 2 plus 4y all squared, subtract 8y squared is equal to 68. Okay, so solving this, guys, I'm going to expand this bracket. So I've not got much space actually. So I'm going to have 2 plus 4y times 2 plus 4y. Here, and I'm going to have a subtract 8 y squared there. Okay, and then I'm going to minus a 68 here to make it a bit easier so we can simplify it in one go, is equal to 0. Remember that quadratic equations have to always equal 0, guys. Right, guys, expanding this one out, okay, I'm going to get 4 plus 8y plus 8y again. So 4 plus 16y plus 4y times 4y is 16y squared. Okay, subtract 8y, subtract 68 is equal to 0. Okay, so collecting like terms, guys, I'm going to get 16y squared minus 8y squared. So I'm going to get 8y squared, okay, plus 16y minus 64 is equal to 0. So 4 minus 68 is minus 64. 16y squared minus 8y squared is positive 8y squared. And then I'm going to have the plus 16y. I'm now going to factor out an 8 to make it a bit easier. So 8 brackets y squared plus 2y minus 8 is equal to 0. So sorry about my work being a bit squashed, guys, I apologise. Factorising that, I'm going to get y plus 4 and y minus 2. So y plus 4 and y minus 2. So solving the solutions, I'm going to get y is negative 4 and x is positive 2. So the y coordinates are going to go here. And what I'll do is I'll put it in like a different colour so it isn't as confusing. So y will be equal to negative 4 or positive 2. And therefore the x solutions, when I sub in negative 4 into the equation 1, okay, or I can do it in equation 3, actually, it doesn't really matter. 4 times negative 4 is 16. Add 2 is going to be negative 14, I believe. Yeah, so that's my answer for that one, guys. And then when y is 2, 4 times 2 is 8, add 2 is 10. So they are my solutions to the quadratic simultaneous equations. So it's a line that intersects a circle, guys. Okay. Right, guys, so we've got 2 more for like today's lesson. So x squared plus 3x minus xy equals 10. I'm going to label that equation 1. And then 2x minus y is equal to 4. Now, this one's a bit more tricky, okay? So it's not as obvious to what subbing actually. What I'm going to do is rearrange equation 2 to make y the subject. So I'm going to bring the y over and the minus 4 over. So 2x subtract 4 is equal to y. I'm now going to substitute that into equation 1 and replace it with y. I'm going to get x squared plus 3x minus x lots of 2x minus 4 is equal to 10. Okay? So expanding this out, guys, I'm going to get x squared plus 3x subtract my 2x squared. Because remember that minus x times 2x is going to be minus 2x squared. And then minus x times minus 4 is positive 4x is equal to 10. Okay, so so collecting like terms and bringing the minus 10 over, okay, or what I'll do is so x squared minus 2x squared is going to be minus x squared, and then I'm going to have plus 3x plus 4x is plus 7x is equal to 10. Okay, bringing everything to the right hand side, guys, I'm going to get x squared minus 7x plus 10 is equal to 0. Okay, so bringing the x squared over, so bringing that to the right hand side, so adding x squared to both sides, it becomes a positive x squared, and then bringing the negative, the positive 7x to the right hand side becomes a negative. Okay, solving this, guys, factorizing it, x minus 2 and x minus 5 is equal to 0, so you can check that by expanding it. Okay, so my solutions are x equals 2 and x equals 5, guys. So they are my solutions. Okay, I can now substitute the x values in separately to work out what y is. So I can sub it into equation 3. 2 lots of 2 is 4, minus 4 is 0. When x is 5, 2 times 5 is 10, minus 4 is going to be 6. So they are my solutions for the quadratic equation and the linear equation, okay? Or the linear graph, sorry. So that is my solution for that, guys. So that was example number 4. Right, guys, last one for today's lesson, okay? Feel free, guys, if you're feeling a bit more confident and happy after watching the previous ones, feel free to pause it and then have a go and then press play if you're happy to have a go at this question. Right, guys, so last one says, how many points of intersection does the circle have with the line? Well, I've got x squared plus y squared equals 8, and I've got x plus y is equal to 4. Now, I've got a circle and I've got a straight line. So what I'm going to do is label that one equation 1 and that one equation 2, guys. I'm going to rearrange equation 2 to make y the subject or x subject. It doesn't really matter. So I'm going to have y is equal to 4 minus x. Okay, so subtract x on both sides. I'm now going to substitute in 4 minus x into equation 1. Okay, and form an equation for x. Or form a quadratic, I should say, for x, and then solve it, guys. Is equal to 8. Okay, right, guys. So this is going to be x squared plus 4 minus x and 4 minus x. Okay, and then I'm going to bring the minus 8 over to the left-hand side, so make it equal to 0, because quadratic equations have to always equal 0, guys, when I solve them. So expanding this, I'm going to get x squared plus 16, subtract the 4x, subtract 4x again, and then plus the x squared. Minus x times minus x is positive x squared. Minus 8 is equal to 0. Rearranging this, so collecting like terms, I'm going to get 2x squared minus 4x is going to be minus 8x. And then lastly, I'm going to have 16 minus 8, which is going to be positive 8, guys. And that is equal to 0. Okay. I can now take a 2 out as a factor and solve it. So I'm going to have 2 brackets x squared minus 4x plus 4 is equal to 0. Now factorizing this one is a special type, actually. So when I factorize this, actually, it's so it's what I call like a complete square, and what that means is so factorize that, I'm going to get x minus 2 and x minus 2, and what that means is that when I solve it, x equals 2 brackets twice, so it is a repeated root. Okay, so x equals 2, okay, because it is a repeated root, guys. When x equals 2, y equals 2 as well, because 2 plus something equals 4. Okay, so this line intersects the circle at 1 point, okay, because the quadratic, okay, factorizes to what I call like a perfect square. So what I mean by that is that the solution is the same in both. Normally when I solve a quadratic, it has 2 different solutions, but this one has the same solution here, guys. So I hope that makes sense. Okay, so it intersects at 1 point. Okay, Right guys, so thank you so much for watching the video. Okay, this video was recorded on the Sunday the 1st of August 2021. Like I said at the start, if you found this video informative or useful, then please drop a subscribe, please drop the video a like, and also turn on post notifications by pressing the bell icon so you don't miss out my regular uploads on this channel. Okay, more videos to come out later this week. My target now is to hit 1,000 subscribers as soon as possible by the end of summer. And lastly, all the questions from today's lesson were from this PDF here from corbetmaths.com. Okay, so feel free to check it out. It's www.corbetmaths.com, and it's looking at simultaneous equations, non-linear ones. Okay, some of them have calculator marks and non-calculator marks. Okay, so yeah, so feel free to have a go and practice, and comment below if there's anything that you're not sure about from today's video. Okay, but that's it for today, guys. Thank you so much for watching. Take care, stay safe, stay healthy, and I'll catch you in the next one. Bye for now.